Hi, Jasmine. I hope you're doing okay. I'll try and go over the simplifying radical sections, and let me know if this helps. So we're going to go simplifying radicals, just so I have a title for myself. Okay, so radicals are these numbers with a square root here. So we're taking the square root of 27 and we need to simplify it. Simplifying it means taking all of the perfect squares out of it. So for 27, let's say I don't know what perfect squares there are. Perfect squares are like 1 squared equals 1, 2 squared equals 4. So like this guy's a perfect square, 4 is a perfect square, 3 squared, 9. So that's my perfect square. So we're trying to see what numbers are have perfect square factors in them under this square root. So you can just know that there are perfect squares, or you can draw a little tree, a little factor tree, to figure it out. So I take 27, I break it up into two numbers that I know. Let's say only two numbers that I know to multiply to 27 right now off the top of my head. Let's say I decide that those are 3 and 9. And then I see, okay, can I simplify these numbers anymore? Or can I break it down so I only look at the numbers that are prime, numbers that don't have anything that multiply into them except for 1 and 3. And so 3 is just 1 and 3, 9 is 3 and 3, and I've got all my factors. To simplify a radical, you look for pairs of numbers that exist. So I have, and you look for those pairs at the end of the factor tree. So this is the end of the factor tree. This is the end. 9 isn't because we broke it down. And that's the end of one of our factor tree here. So I look for pairs. So I need a buddy to leave the house. I need a buddy to leave this square root. So 3 has a buddy, so it can leave the house. So I've got 2 3s here, meaning 1 3 can leave the house. And I notice that I've got this 3. It doesn't have a buddy, so it stays in the house. So this is its simplified form. We were able to take out any perfect squares by looking at this factor tree. We're going to do a lot more, a couple more. So let's say I take square root of 72 and I need to simplify it. So I got to break it down into its prime factors, numbers that can't be broken down anymore. So 72, what two numbers multiply to 72? I'm going 8 and 9. So then I go 4 and 2, 2 and 2. So that 2, this 2 right here couldn't get broken down, but the 4 could. And then 9 breaks down into 3 and 3. So I look at the ends of the tree. 9 isn't the end, so I don't look at it. 8 isn't at the end because I broke it down. 4 isn't at the end because I broke it down. So we only look at the numbers at the very end of my factor tree. Do I have buddies that can leave the house? Do I have pairs, meaning I've got perfect squares? Do I have pairs that can leave the house? I've got a 2 and a 2 here, so a 2 can leave the house, and a 3 and a 3, so a 3 can leave the house. So a 2 can leave the house, and a 3 can leave the house. I'm going to multiply them. And then there's one number that wasn't circled that didn't have a buddy, so it can't leave the house, and that's the 2. So I'm left with 6 rad 2. So you need a buddy to leave the house. You need a buddy to simplify your radical. And let's add a blank page here. Let's do a bigger number to check if we can simplify our radicals here. Let's say 175. Okay, off the top of my head, I maybe don't see it, but it ends in a 5, so it's probably 5 times something can give me 175. So let's figure that out. So I go 175 divided by 5. that helps me get 35. So that helped me out. It doesn't matter what you break it up into because at the very end, you'll get the same prime factors. And that'll be 5 and 7. Okay, so we're looking at the ends of our tree. So 5, 5, 7. Those are the ends. 35 was broken up, so it's not part of the buddies that can leave the house. So we have that 5 has a buddy, so it can leave the house, and then I'm left with 7 that can't leave the house. So 5 can leave the house because it had a buddy. 7 can't leave the house because it didn't. And that's our simplified reciprocal right there. Hopefully that helps.